All right, I said I'd give you another example, so here's the example we have today. Notice we're solving for theta in between negative pi and pi. So the problems in your book have you solve from negative 180 to 180. I wanted to show you what that might look like. So I'm going to do it in radians instead of degrees. So here's the problem. 1 plus tangent 4 theta is equal to 3 minus square root 3 over 3. So don't be intimidated by this problem. This fraction, okay, is not that scary once we work with it. So we're going to start by subtracting 1 from both sides. Okay, so we'd have tangent of 4 theta is equal to, now off to the side I'd do this. I'd do 3 minus square root 3 over 3 minus, well, what is 1 with the denominator of 3? Well, it's 3 over 3. All right, so when you subtract these, you notice the 3's cancel out and you're just left with negative square root 3 over 3. So see, that cleans up nicely. So now we take the inverse of both sides, so we'll end up with 4 theta is equal to inverse tangent of negative square root 3 over 3. Now we need to find the angle that produces this ratio. So using our hand, this is unrationalized, the same thing as square root 1 over square root 3. So using our hand, that's going to be the 60-degree angle, or excuse me, the 30-degree angle, but it's in the second quadrant, right? The second quadrant, because that's the first place the tangent is negative. So we get 4 theta is equal to, well, what's the second quadrant angle that has a reference of pi over 6? So we're looking for this angle right there. So that's 5 pi over 6. Now remember, when we talked about the period for tangent, the period of tangent graph is pi. Okay, the other angle would be in the fourth quadrant, right? But the distance between those angles is pi, and you see that from the tangent graph that we drew yesterday in class. All right, so all the solutions can be found by using this equation, but we don't have theta by itself. So what do we need to do? We need to divide by 4. So we'd have theta is equal to 5 pi over 24 plus pi over 4n. So that's the rule that tells us how to find all our solutions for any theta. All right, however, we have a restriction. We need to follow this restriction between negative pi and pi. So here's what I'm going to do. I'm going to say theta is equal to, I'm going to start with this angle that I know. And then I'm going to figure out what the next angle would be. So all I have to do is add pi over 4, which is the same thing as adding, if we're in denominator of 24, 6 pi over 24. So I'm basically adding 6 pi to 5 pi to get 11 pi over 24. And because the denominators stay the same when you add, I notice I'm just adding 6 to the top. So 17 pi over 24, that's still less than pi. Then 23 pi over 24. The next one would be 26 pi over 24, which is past pi. So that's as far as I can go to the right. Now let's figure out our solutions to the left. Well, the solutions to the left, if I'm going that way, I'm going to subtract pi over 4. Okay, or subtract 6 pi over 24. So I'm going to subtract 6, so I'm going to get negative pi over 24, then negative 7 pi over 24. Need more room. Then we get negative 13 pi over 24. Then I'm going to have negative 19 pi over 24. And then the next one would be negative 25 pi over 24, which negative 25 over 24 is negative 1, which is past this negative pi. So here are my solutions. So on a normal trip around the circle, you're going to have two solutions, right? 5 pi over 6, and then you're going to have this fourth quadrant angle, which we didn't need to find because it was included in this solution. So we would normally have two solutions. Remember this value here, if you take the amount of solutions that would be in a normal period for the normal parent function, if you multiply them by that value, that tells you how many solutions you should have over any given period. So we have 8 solutions here. 2 times 4 is 8. Hope this helps. See you guys Tuesday.